All right. I hope I'm visible to everyone. Can someone confirm in the chat? Also for the audio as well. Okay, I am visible to everyone. Okay, cool. Okay, let's wait for a minute for people to join. Okay, so as always, we are going to be solving all the problems of CodeChef Starters, June CodeChef Starters. There are 6 problems. Okay. All right. We only have 2 people watching. Okay. So let's wait for like 2-3 minutes for more people to join. And in the meanwhile, let me just quickly get done with the Unacademy subscription. Okay. So first, a little bit about me. My name is Naman. I am working as a software developer at Adobe. Before this, I was working as a member technical at DE Shaw. I used to be a candidate master on Codeforces. Right now, I am an expert myself, and I am a 5-star coder on CodeChef. Now I take subjects related to competitive programming, data searches, and etc. For now, I'm solving every contest of Codeforces and CodeChef on this YouTube channel. So yeah, make sure to subscribe the channel if you are not. Then Unacademy has brought many batches in the month of June, 4 to be accurate. So there is a Love batch, which is an 11 months course for beginners, but it is only for people who want to do DSA in Java. Then for Python, we have Python Expert. And then we have Brahmastra. This is only for people who are actually preparing for interviews, whose placement season, we know that placement season is coming around. So this course is mainly for those people. Then we have Adroit 2.0, which is a 9-month course, which is a very beginner friendly course. Okay. So these are the different courses that were launched in the month of June. There are many other courses which were launched in the month of May, April, etc. These are the basic things that you get from Unacademy if you get the subscription. Now, if you get the subscription, you're not going to get only 1 course or 2 courses. You are going to get access to all the courses of that year. Okay. So basically, if you get the subscription now, let's say for of an year, then for the complete year, you will be able to access all the contests and courses of Unacademy. Okay. Yeah. So that's it. This is the subscription plan. So as you can see, 12 months is the best one. You can even use my referral code, which is NBYT, and it is going to give you a discount of 10%. Okay. So yeah. Okay, cool. All right. Yeah, and you can even follow me on Unacademy. The URL is unacademy.com/nounbansal013. So yeah. All right. Okay, so we have, sir, you're also teaching. Yes, I am teaching, Priya. So I'm going to be solving all the questions of today's June CodeChef Starters. Okay, we have 7 watching. Okay, cool. But actually like to know from the people like how many they were able to solve today. We don't really have many people watching for now. But yeah, if someone can reply, that would be great. Okay. Today's stream will be very small, I think of 30 minutes only, because the first 5 questions are very easy. Okay, let me tell this as well. So basically, if you look at Div1, this is the standings in Div1, and in Div2, in Div3, okay, this is something else. CodeChef Starters. Then if we go to Div3, you will actually see that Chef and Queries is actually on the 4th number, and in Div1, it's actually on the last number. The reason for that is actually because first I thought it is because of massive cheating, but I kind of thought that not that many people cheat. Then I actually looked into the submissions. So if we go into the submissions, you'll actually see that if I just open up the topmost submission, you'll actually see that people have written a complete brute force and it is passing for all the test cases. So otherwise, if you see, this question is actually of RMQ. Okay, and it involves segment trees. So I don't really expect anyone in Div3 or Div2 to solve this problem. Okay, And if you're able to solve it using segment trees, then I don't think you should be in Div-3 or Div-2. Okay, so yeah, so I'll actually be skipping the last problem because I don't really think it is of any use for the viewers. Okay, but I'll like explain the problems 1, 2, 3, 4, and 5. For the last one, I don't really encourage you to submit the brute force approach because that is a wrong like way to submit it. Although I didn't really expect this from CodeChef to do such a mistake. But yeah, anyways, so let's close this. And should we start now? I think we should start. We have already used like 7 minutes of the stream. So okay, so let's start with the very first problem, which is cyclic quadrilateral. Okay, Priya says 3, Ratik says 4, Kushal says top 4, Jyoti says top 5. That's really nice, Jyoti. GB Kulam says 4, Hit Shah says 2. Okay, cool. So everybody's gonna know the solution of rest of the problems today. Jyoti says I got TL in Python but works in C++ for last problem. By last problem, do you mean chef-in queries? If yes, I'm pretty sure you got the last problem using without using segment trees, and you just wrote a brute force. So anyways, you should get a TLE in C++ as well. But considering that the test cases are very bad, that's why you're able to pass in C++. Okay. All right. So let's look at the very first problem. You're given the sizes of angles of a simple quadrilateral in degrees A, B, C, and D in some order along its perimeter. Determine whether the quadrilateral is cyclic. Now, so basically, we are given a random quadrilateral. Let's say this is a quadrilateral. Okay, let's say this is a quadrilateral. This is actually a trapezium, but yeah, let's say this is a quadrilateral. This is A, this is B, this is C, and this is D. Okay, so what they want is they want us to tell if this is cyclic or not. Now, for a quadrilateral to be a cyclic, A plus C should be equal to 180 and B plus D should also be equal to 180. Okay, so yeah, that is all you have to do. You just need to scan all the 4 values and then check for these 2 conditions. If both of them are passing, then we can say yes, otherwise we'll say a no. So if I quickly show you the code, cyclic quadrilaterals. Okay, so this is the code. I'm taking all the values in an array of size 4. So I just scan all the values and then I say 0 plus 2 equals to 180 and 1 plus 3 equals to 180. Then I print yes, otherwise I print a no. So yeah, and that's it for this problem. Very like easy, straightforward problem. And I can see that everybody was able to do this. All right, so let's move on to problem 2 now. I'll actually quickly like solve all the problems today because I don't really think there's much to explain except the last problem, like the 5th problem. Okay, let's go to chess match. Okay, so in a chess match, A plus B, each player has a clock with, okay, so basically they are actually explaining how a blitz match actually occurs. So basically what happens is, okay, so what they've written is 3 plus 2 blitz. What this means is that the game is of 3 minutes. Okay, and at every turn, every player gets a plus 2 seconds. So this is what this 3 plus 2 blitz chess match means. Okay, so basically what they want us to tell is, they basically say that we had 2 clocks in the starting, both of them read 180 180. The reason we have 180 here is because it's a 3-minute game. Therefore 3 into 160, 3 into 60 is 180. So both the clocks are actually reading 180 in the starting. Let's say the very first player took a turn in some x seconds. Basically right now the clock will read 180 minus x. But since he has taken a turn, 2 seconds will be added. And similarly, for the other player as well, if he took y seconds, then it will be 180 minus y plus 2. And that is how the game is going to like go on. So basically after every turn of every player will get a plus 2 addition. Okay. So yeah, so that is the complete problem. So basically what they want us to tell is that in the end, they saw that the first clock read A and the second clock read B. And now they want us to tell that how much was the total duration of the game. So basically, let's look for player A. Now, player A had started from 180 seconds and is left with A seconds. And let's say he did any X number of moves. Sorry, what do we? Yeah, X number of moves. So basically, he will be added X, right? This is for player A, and similarly for player B. Player B will say that I had 180 seconds I was left with b seconds in the end, so I'll subtract that, and I made 2 into y. Let's say like he made y turns. Okay, so basically these are the complete timings. Okay, now let's add these two timings. The total timings become 360 plus 360 minus a minus b plus 2x plus 2y. Now if you see at these two values, this is 2 times x plus y, and we are already given in the like question that there are in total n turns, and since x are the turns of player A and y are the turns of player B, we can say that x plus y is actually equal to n. So we can actually substitute this value with 2 times n. Okay, so this is the complete duration of the match. So basically you just need to scan everything which is n, a and b, and then you just have to print the value of this equation. So if you like, if I just show you the code, you can see that I have 360, which is this 360. Like after scanning n, a and b, I have 360. Then I add 2 times n, and then I subtract a plus b, like minus of a plus b. That's all. So that is all you had to do for the second problem. I am pretty sure like everybody was able to do this. I can see that everybody was able to do this. Okay, let's move on to problem 3 now. I don't really think anyone has an issue with the second problem. If anyone still has, they can just comment down below, or they can like write it in the live chat and I'll just explain it again. Okay, cool. Let's go to total correct submissions. Okay. Okay. So the third question says that CodeChef challenges have 3 divisions. In one challenge, there are n problems in each division, but some problems may be shared among multiple divisions. Each player is uniquely identified by a code. So basically, there are n problems in each division, and we have how many divisions? 3 divisions. We have Div-1, we have Div-2, and we have Div-3. Okay. Now every division has n problems. Okay, but some of the problems are shared between Div-1, Div-2, and Div-3. This is the usual way how CodeChef works. Okay. Now, each participant can only submit in one of the divisions. So basically, every submission will be counted either in this one or in this one or in this one. No submission will be counted twice. Okay. Now, Chef wants to find the number of correct submissions in total among 3 divisions. For each problem, given a list of n problem codes with the number of correct solutions for each problem in each division, find the total number of correct submissions for each problem and sort them in non-decreasing order. So let me just go to the input and let me explain that. So basically, what they're trying to say in the first example is that there is one problem only. So basically, in Div-1, we had one problem. The name of the problem was A, and there was one submission. Then in Div-2, we had one problem only with the name B, and there were 2 submissions. Then in Div-3, we had one problem only with the name C, and there were 3 submissions. Okay, now in the end, what they're trying to ask is that we need to print all the total number of submissions for every problem in non-decreasing manner. So basically, the total submissions for A are 1, total submissions for B is 2, and total submissions for C is 3. And these are the only 3 problems that we have in total. So we just need to print all these 3 values in non-decreasing, and since these are already non-decreasing, we just print 1, 2, 3. Now let's move on to the second example. I guess that's a better example. Okay, so if you look at this example, so Div-1 had 2 problems. So let's write these 2 problems. Basically, we had AA and AB, and AA had 1 submission and AB also had 1 submission. Now the second div had AB and AC. So we had AB and AC. AB had 1 submission, AC also had 1 submission. Then in Div-3, we had 2 more problems, which were AC and AD. Okay, so we had AC and AD, and both of them had 1 submission. Now, if we count all the total distinct problems that we had, so we can say that we had AA, we had AB. So basically, this is AA. Then AB we have here and here. So that is covered. Then we have AC. This is AC, and this is also AC. And then we have AD. This is AD. Now let's count the total submissions of AA. So we have 1 submission. Then for AB we have 1 here and 1 here. So this is 2. Then again for AC we have this one and this one, so we have 2 here, and for AD we have 1. Now the submission list is 1, 2, 2, 1. Now we just need to print these in non-decreasing manner. So the answer will be 1, 1, 2 and 2. And as you can see, the answer is 1, 1, 2 and 2. Okay, so yeah. Now, now how to write the code for this? Basically, we can actually use a map here. If we make a map of string, let's say, with an integer, what it is actually going to do is whenever a same string comes, it will add for that particular value only. So basically, if I show you the code of this problem, okay, so yeah. So basically what I did was I actually took a map of string long of m, and when I'm scanning every s and x, so basically s is the like problem name and x is the total number of submission. I'm just doing m of s plus equals to x. So basically if AB was already there, so basically if in the map we already had AB with the count of 1, when again an AB comes, this 1 will be counted for this AB only and this will become 2. So basically this map will be generated using this particular for loop only. We don't really need to do anything extra for this. Then the we needed to like print all these like total submissions in non-decreasing manner. So what I did was I actually like pushed back all these values into a vector. Okay, so this is 1, 2, 2, 1 is a vector now, and I just sorted them. So basically I just pushed back them and then I sorted them, and then I just printed all the values. Okay, so yeah, that's it for the third problem. Again, not much to do in this one. If you know how to use STL and like data structures, it is a very easy and a very fast problem. Okay, all right, cool. So let's move on to the next problem now. If anyone, okay, Heth said 3 wala अच्छे से बता. Okay, cool. I'm sure like you are able to understand the solution now. If not, you can just comment in the live chat and I'll just tell the solution again. Okay, cool. Okay, let's move on to the fourth problem, which is sleep cycle now. All right. So I use the same logic, but I used unordered map. Yeah, like not a. You could use an unordered map also. Not much of a difference. Okay. Without using map, how can we do that? Without using map, we will actually have to compare the string with all the previous strings. Okay. And in order to do that, you will actually have to go for an O of n loop, which will give you a time limit. That is why you can actually use a map which will actually do the same thing in log of n. Okay. Yeah, you cannot do that. So basically you'll have to use a map only or something in lines with map which will actually do the operation in log of n. Okay, cool. All right, so let's move on to the next problem, which is sleep cycle. All right, sleep cycle is a good problem. There is one case that we need to consider while like solving this. So basically the problem says that chef has been studying the human cycle, sleep cycle for years. He divides a day into L units of time. So basically we in total we have L units of time. Okay. All right. Now he divides a day into L units of time numbered from 1 to L. So we have 1 here and this is the complete day. Okay. Chef research shows that his body requires spending only H continuous units of time per day on sleep. So basically H units of sleep is needed. Of sleep. But this has to be continuous. Okay. Alright, cool. So then he can stay active during work. However, in case of travel or any other responsibilities, he might not be able to achieve this idle state. Next, Chef noticed that if he sleeps for X continuous units of time and then performs some other activity, he can still meet his daily sleep quota, but the remaining time he needs to spend on continuously sleeping becomes 2 times H minus X. So basically, if he slept for X units of time, then the remaining time will be H minus X. But now he will have to sleep for 2 times H minus X continuously. Okay. But again, this pattern will follow. So basically, let's say after this, he slept for Y units of time. Now, this was the time he had to sleep, but he slept for only Y minutes. Now, again, the remaining time will be 2 times of this. Okay. So that is the complete problem. So basically, every time you sleep, the remaining time gets doubled. Okay, because like let's say like in the starting when we slept, the remaining time was h minus x, so this was doubled. Then when we slept for y units, the remaining time was this and this got doubled. So that is the complete problem. Okay, now you need to, okay, so what do we need to do? You are given a string s with length l. For each valid I, the ith character of the string is 0 if the ith unit of time is free, or 1 if it is occupied. So basically we are given a string of zeros and ones. 1 means he's working and 0 means he is free. Now he can either use his free time to sleep or he can actually be free only. Okay, now so basically we do not have to use all the free like zeros, we can even skip some zeros. Okay, can Chef ever get enough sleep to feel fresh during his work, given that he can choose when to sleep in his free time? Okay, so basically an ideal case will be if the time was not getting doubled, we would actually like find out all the continuous zeros. So let's say we had a continuous zeros here, then we had here, then we had here, and then we had here. So basically we would actually take all these values and sum them up and then find out if that was greater than h, then we can say that he's able to sleep well. Otherwise we can say he's not able to sleep well. But right now the time is actually getting double. Now how to do this? So basically let's say that, let's just skip it. Okay, let's say there were 3 sections of sleeping times. Let's say we had x, then we had this y, and then we had this z. Okay, now let's say that we took the very first option and we slept for x minutes. Now the remaining time becomes h minus x. Okay, now we know that we actually need to sleep 2 times h minus x in order to sleep well. Now when this section of y unit comes, which we can use for sleeping, let's see how many units will be decreased. If he sleeps for y, okay, so basically if he sleeps for y minutes here, then his remaining time would be 2 times h minus x minus y. Okay, so let's write, and this complete thing is multiplied by 2. Okay, or more importantly, let's say that in the starting he had h, like he had to sleep for h minutes, h units. Let's say there were 2 options. When this x came, there were 2 options. He could either sleep or he could be free. Okay, let's consider this for sleeping and this, let's consider this for free. If he is free, the remaining time will be h only. But if he sleeps, the remaining time will become h minus x times twice. Now there might be a condition that this value is actually greater than h. If this is greater than h, then there is no point of sleeping, because without sleeping he had less time to sleep, like he had to sleep for less time. Therefore it is not beneficial for us to sleep at this state. We can actually skip this section and look for the other sections, and that is all we have to do. So basically if I show you the code for this, okay, so this is sleep cycle. Okay, so if you look at this, the very first thing that I'm doing is I'm actually counting all the continuous sizes of zeros that we have. So that is being done here. How I'm doing that is basically I actually have a count variable which is equal to 0. Then if si is equals to 0, then I can just count plus plus. If it is, okay, if si is not equal to 0, that means if it is equal to 1, then I just check. If my count is not equal to 0, that means before this one I had some continuous zeros. Then I just push back all these this count into a vector and I make count equals to 0. Now this is something that usually many people miss. After completing this loop also we need to like push the value, because there might be a condition that we'll have 1 0 1 0 0. Now for this 0 we'll push back 1, but for this 2 zeros we'll have count is equal to 2, but we will never push these values. So basically after this for loop also you'll have to like make a condition that if count is not equal to 0, we need to push these values. Okay, so basically after this I have all the continuous streams of zeros in this vector, the lengths of them, I have all of them in a vector. Now I just iterate over this vector. Okay, and then I see, okay, so h is the time that I have to sleep. If this h is actually like less than equal to the current continuous stream of zeros, then I can say that he will be able to sleep in this section and he will be like done with his sleep. So I can just break out of this loop. Okay, but if that's not the case, I need to check if 2 times h minus x, so basically 2 times h minus x here is it. If that is greater than h, then there is no point of sleeping. No point of sleeping. So I need to skip this value. That's why I'm just writing continuous here. But if that is not the case, I can just like subtract that value from it and I can multiply this h by 2, because that will be the remaining time. And that's it. So basically in the end, I'll just see that if h is equals to 0, that means I was able to sleep well, and I can just print yes, otherwise I'll print no. Okay, is this clear to everyone? I kind of think that I went very fast with the solution. So if it is not clear to everyone, I can just explain it again, some parts of it again. So the only thing that you had to actually look for was this condition, and that's all. And if you just like the video so that I can see that people are able to understand the approach, instead of like writing yes, yes, you can just write like the video as well. Vishal says clear, that's really nice. Okay. All right. All right, let's move to the next problem now, which is Flappy Bird. Okay, cool. Okay. Okay, so let's read out the problem once. Chef is playing a new version of the game Flappy Bird with the following rules. The bird start at height h. So basically in the starting, the height is h and he is at x equals to 0. There are n obstacles numbered from 1 to n. For each valid I, the ith obstacle is at position xi and it has a height hi. So basically, if this is a number line, we have x1 here, like let's say x0 here, x1 here, x2 here, and x4 here. And let's say we have some height here. So this is one height, this is other height, this is another height, and this is another height. Okay. Now for each integer, Chef has the option to click once when the bird is at x equals to I. Let's denote the bird's height y coordinate at that point be j. If he clicks, the bird moves x equals to I plus 1 and y equals to j plus 1. Otherwise, it moves to x plus 1 and j minus 1. So basically, if he is at this position, okay, if he is at this position, now in the next turn, he can either move upwards by clicking here. If we click, then he moves at this position. If we don't click, then we go one step down. Okay, so that is how the game is working. Now there is no ceiling and all the obstacles extend upwards from the bottom, not the other way around. So basically everything is above the sea level, not below. For each valid I, the bird crosses the ith obstacle successfully if the bird's height at x equals to xi is strictly greater than hi. Basically, if this is hi, the height of the bird should be at least 1 greater than that. Okay. Yeah, okay. Cool. Okay, someone had some issue. Can you explain the last part? Okay, got it. Okay, cool. That's perfect. Okay. So yeah, that is all. So basically the height has to be greater. At any point before x equals to xn, the bird's height should remain non-negative, otherwise it will drown. Okay. If the bird crosses the nth obstacle successfully, Chef wins the game. Now, so basically, okay, so can you tell Chef if he can win the game, get the bird to cross all the obstacles and the minimum number of clicks required to win us in such a case? Let's forget about this minimum clicks problem now. Let's just try to find out if he's able to like complete the game or not using any number of clicks. So basically, if you see, every obstacle is actually above the ground, and there is no ceiling. We don't have any ceiling. So basically we can move at any height without any problem. And the only issue that we have is whenever we so basically if we click at every position, our height will always be increasing, and that is the best possible case. So basically what you can do is, if this is x equals to 0 and this is the last x4, what you can do is the distance between this and this is x4. The distance between this, okay, this is x3 actually. This is x3. The distance between this and this is x2. The distance between this and this is x1, and distance between this and this is x0. Okay. Now, if he starts from this position and let's say this is h, his height, like the height of the bird at x0, the maximum height that it can achieve will be h plus x0. Sorry, let's write it here, h plus x0. The reason for this is because at every index he's going to click and height will increase by 1. And since the distance between this and this is x0, the height will increase by x0. Similarly, for the second case, the height will become h plus x1. And similarly, for the other case, the height will become h plus x2. For this case, it will become h plus x3. What we can do is, we can iterate this complete array and check for every index if the height is greater than the given height. If it is, that means a solution exists, otherwise no solution exists. Okay, so that is the first part of the problem. With this, we can check if a solution exists or not. Okay, now we need to find out the minimum number of clicks required to win the case. Now, how to do that? So let's just try to analyze this game for a minute. Okay, basically, let's say, okay, let's try to find out. Let's say we were at some position x. Let's say we did 2 continuous clicks after this, +1, +1, and then we did not click, then we had a -1, then we had a click, so we had +1, and then we again say did not have a click and had -1. Okay, let's try to find out the final position of this. The final position, let's say this is height h. Okay, this height will actually become h plus 1 plus 1 minus 1 plus 1 minus 1, and this actually becomes h plus 1. Now let's try to reorder all these operations. Let's say we put all the positive operations first and then we put all the negative operations. So basically, if we write +1 here, +1 here, then we swap this +1 with this -1, we have +1 here, then we have -1 and -1. Now again, if you see, the height using these operations will also be h plus 1. So basically, if you are at any index, let's say if we are at x2 index, and if we made like p positive operations and we had n negative operations, then the total height will become h plus p minus n. There is we don't really need to look at the ordering of this. We can just find out the total height in the end by h plus p minus n. Okay, now, okay, I believe this is clear to everyone. Okay, all right, cool. So now, so basically the idea of this is that if we actually fix the total number of clicks that we are going to do, let's say the total number of clicks that we are going to do is p. Okay, then n is actually going to be equal to, okay, let me erase this. And let's say this x3 is the total distance. Then if p are the total clicks, then n will actually be equal to x4 minus p. And since we have already established that ordering doesn't matter, we can actually make all the p clicks first. So basically, the height will keep on increasing for the first p seconds. Okay, let's say if this is the p distance, then the height will keep on increasing for the first p seconds, and then for the rest of the path, it will keep on decreasing by 1. Okay. And that will be the best case how we can do this. Okay, now I'm pretty sure many of you might have already gotten the solution of this. So basically we can use binary search here. We can fix this p. Okay, let's say that we fix any number of p's, we find out the maximum height, and then we make it go down, and then for every index we can just check if the height is greater than the given height. If it is, then we can just say that we are able to find a solution for this, and then we can divide a subset into a much smaller subset. So if I show you the code, okay, Flappy Bird. Okay, so basically what is happening is, in the very starting I have POS as the position, then I have height I as the heights. Then what I do is, for every index I just check if height is less than POS plus h. That is what I wrote. So basically the position plus the initial height. If that is greater than the given height, then we can say that it is okay. Otherwise we can just say flag equals to 1 and break, because it will hit the what do we say, obstacle. And if flag is equals to 1, we can just print -1. Now after this, if we are able to see that we will be able to complete the game, we need to find out the minimum number of clicks. For that we are using binary search here. So basically I have L equals to 0, R equals to infinite. Infinite is actually 10 to the power 15 for me. So we just need a random big number. Okay. Then I just have the standard binary search here. So basically I have the middle element, which is L plus R by 2. Then how do I check if I'm able to find out the like if I'm able to pass the game using those number of clicks. What I do is, if my x is less than the total, like this p, which is the total number of clicks, then I go into this condition, otherwise I go into this condition. Okay, so basically why I have made two conditions is because if I am somewhere between this and this, I know my height is increasing. So basically my height at any point will be position plus the distance of my current index. If that is greater than the height at that particular index, then I can say that I just should just continue, otherwise I can break out of this. But if my point is somewhere like after this p, okay, if my point is sometime after that, then what is my height? Let's try to find out. So basically this is m for now, that m is the total number of clicks. So basically we increase our height till m, and then we decrease our height, and let's say we had to find for this particular index, and let's say this is x2. Let's try to see what is the height at, like how to find out this height. Now to find out this height, can you give a try run why with this case for a Flappy Bird logic? Okay, I'll do that in the end. Okay, now height, how to find out this height? So basically if you see, my total height would be okay, h plus m till this point. Now for this particular distance, my height will be decreasing, and this distance is actually x2 minus m. So basically this is x2 minus m, and I need to subtract this value because for every index my value will decrease. So this is the height at this point. If this is greater than x2, sorry, h2 is the height at this point. If this is greater than that, I can just continue, else I can break out of this with the flag 1. And if flag is equals to, yeah, now if flag becomes 1, that means I was not able to complete the game, and I can just make l equals to m plus 1. Otherwise I can make this answer and r equals to m minus 1. Okay, so I believe this is also clear to everyone. Again, not much to do, usual binary search. All you had to do was look that it is a binary search problem. After that, everything is easy. Okay, can you give a dry run with test case for the Flappy Bird logic? Okay, I don't really have to give a dry run because you can actually look at the figure. So this is the figure for which problem, which case, x equals to 1 and 3. Okay, this is the figure for this case. Okay, so basically we have two indexes, like two obstacles. One is the starting height. We have one obstacle at x equals to 1 and one obstacle at x equals to 3. At x equals, both the obstacles are of height 1. So basically he makes the first click here. Okay, then his height becomes 2 at x equals to 1. Now since this is great, this 2 is actually greater than 1, we can just say that we are able to like pass this obstacle. After that we don't click, therefore the height decreases by 1. But then we again click and the height increases by 1, and right now the height again becomes 2, and the height of the obstacle was 1. And since I have been able to like pass both the obstacles, I can say I am able to complete the game, and the total clicks are 1 plus 1 2, and therefore the answer for this is 2. Okay, I believe everybody gets the solution now. All right. Again, this I would say was a good question for Div-3. Like many people might have learned binary search from this problem. All right. Okay, I think I'm gonna like end the stream now because we are done with the 5 problem. The 6th problem is actually of segment trees, and there is not much like use of solving this here. I myself don't really know how to do it exactly. But if you're in Div-3 and you're scared that why this problem is on the 4th number, that's because the test cases are really bad, and even if you write a brute force solution for this, it will pass. So don't really worry about this problem. Okay, you can just do all the rest of the problem. Okay, so if anyone has any like queries, they can ask me, or else I'll just end the stream. Mm, I think there is a little lag, that's why I haven't really been able to look at the chat. Vishal says, thank you, sir. Okay, cool. Perfect. Thank you, Vishal, for watching the stream. Okay, cool. I don't really see anyone like with any doubts, so I'm gonna end the stream. Thank you for watching. If you like the solution, just make sure to like the video, share with your friends, and subscribe to the channel. Show the code. For which problem, Atisha? By the way, you can even go to my account also. I think, and you can yeah, you can even go to my account. I think that is possible. You can like go to my account. You can search for my account, and then you can actually look for the submissions in my recent activity. Okay, you can even do that. Otherwise, I'll just show you the code for one more second. I think you are asking the code for problem Flappy Bird. This is the code. This is the binary search. I'm just showing the binary search here. You can see, like, take a screenshot of the code if you want. Okay. Okay. Class. Okay. I hope you are able to see the code now. Okay, cool. I'm gonna end the stream, and I hope everybody enjoyed the stream. Just make sure to like the video and subscribe to the channel if you're not subscribed yet. And that's it. Thank